New Syllabus Mathematics, Book 2, updated 7th edition, Exercise 1B, question number 10. The LCM of 9, 12 and n is 252. If n is odd, find all the possible values of n. To find the possible values of n, first I'll factorize 9, resulting in 3 times 3. Then I'll factorize 12, which gives us 2 times 2 times 3. Since the LCM of 9 and 12 is 36, therefore I'll multiply 36 by different numbers to get 252. There might be another method to find the possible values of n, but this method is quite easy. All you have to do is prime factorize the numbers 9 and 12. Next, find out their LCM, which is 36. Multiply 36 by different numbers until you get the number 252. First, if I multiply the LCM 36 by 1, we get 36. Here, 1 is the possible value of n, which we assumed. But the LCM of 9, 12 and 1 is 36, not 252. So our assumption is wrong. Our next assumed number is 3, not 2, because it is clear in the question that n is odd, while 2 is an even number. Therefore, I'll multiply 36 by 3, which gives us 108, not 252. So our assumption is wrong. Our next assumed number is 5, not 4, because n is an odd number. Therefore, I'll multiply 36 by 5, which gives us 180, not 252. So our assumption is wrong. I'll continue the process until we get 252. Now, if I multiply 36 by 7, which is the next odd number after 5, we get 252. Here is the factorization of 9, 12 and 7. This means our assumption is correct because the LCM of 9, 12 and 7 is 252. Therefore, we can say that the first possible value of n is 7. Look, we multiplied the LCM of the given numbers 9 and 12, which was 36, by different odd numbers to get 252. And we did find our required number 7, as the LCM of 9, 12 and 7 is 252. So our first possible value for n is 7. Now let's look for other possible values of n if there are any. For the other possible values of n, I'll multiply the first possible value of n, which was 7, by 2, giving us 14. Now, 14 as an even number, while the value of n is an odd number. Next, I'll multiply 7 by 3, resulting in 21, an odd number. 21 might be the second possible value of n. Let's check it out. Here is the factorization of 9, 12 and 21 to find their LCM. Their LCM is 252, which confirms our assumption. We have found the second value of n. Let's see if there is any other possible value of n. Now, if I multiply 7, which was the first possible value of n, by 4, we get 28, an even number. Remember, n is an odd number. So let's multiply 7 by 5, which gives us 35, an odd number. Since the LCM of 9, 12 and 35 is 1260, not 252, therefore 35 is not the true value of n. For the next possible value of n, multiply 7 by 6 to get 42, an even number. For the next possible value, I'll multiply 7 by 7, resulting in 49. Since the LCM of 9, 12 and 49 is 1764, therefore 49 is not the true value of n. For the next possible value of n, if I multiply 7 by 8, the result is an even number, 56. Therefore, I'll multiply 7 by 9, resulting in 63, an odd number. 63 is another possible value of n because the LCM of 9, 12 and 63 is 252. I'll stop here because I have checked the 19 multiples of 7, but I did not find any other multiple of n that satisfies the condition. So these are the possible values of n: 7, 21 and 63. Another hint I want to share with you is to only consider the values of n whose prime factors are 2, 3 and 7. This is because 252, which is the LCM of 9, 12 and n, contains only these three prime factors. And last but not least, the steps that are done in red are just for your clarification. So consider it as rough work. The neat solution is done in black. Question number 10. Determine whether each of the following statements is true or false. If it is true, explain your reasoning. If it is false, give a counter example. First part from this question. If 6 is a multiple of a number, then 12 is also a multiple of that number. Well, this statement is true. I'll explain it as follows. We know that 6 is a multiple of numbers 1, 2, 3 and 6. In other words, all these numbers have 6 in their times tables. However, 12 is also a multiple of these numbers, which means that 12 appears in the times tables of numbers 1, 2, 3 and 6. Therefore, the statement is true. Second part from this question. If 12 is a multiple of a number, then 6 is also a multiple of that number. This statement contradicts the first statement. It is clearly false. As mentioned in the explanation, we can find 12 in the times tables of 4 but not 6. Therefore, it is incorrect to say that if 12 is a multiple of a number, then 6 is also a multiple of that number. Third part. If 18 is a multiple of a number, then 18 is divisible by that number. This statement is true. For example, 18 is a multiple of 6, so 6 is a factor of 18. Additionally, 18 is divisible by 6. We also know that a number is always divisible by its factor. Therefore, the statement is correct. Fourth part. If m is the LCM of p and q, then m is divisible by both p and q. This statement verifies the definition of LCM, where LCM defines the least number that is exactly divisible by two or more numbers. Therefore, if m is the LCM of two numbers p and q, then m is the least number that is exactly divisible by both p and q. Take a look at this example. The LCM of 10 and 15 by prime factorization is 30. In this case, 10 is represented as p and 15 as q, while 30 is denoted as m. Since 30 is the LCM of 10 and 15, both 10 and 15 are factors of 30. This implies that 30 is divisible by both 10 and 15, confirming the given statement to be true, which states if m is the LCM of p and q, then m is divisible by both p and q.